Hello, and thank you for taking the time to join this talk. My name is Jen Thomas, and I'm a data manager for the Swiss Polar Institute. I'll be presenting How to Stop Reinventing the Wheel, a data management case study, on behalf of colleagues at EMODnet Physics, the Swiss Data Science Centre, and the Swiss Polar Institute. So over the past 4 years, the Swiss Polar Institute has adopted a number of existing tools and services to manage data from a recent expedition. And the aim of this work was to ensure the data were securely stored for the future and well described. It's important to note that we didn't work on the majority of the processing of the data. That wasn't our role. This was more the responsibility of the researchers. But we did want to assist them in making sure that the data would be openly and freely available for the future. So the data we began with was from a cruise which circumnavigated Antarctica in the 2016-17 season. And it produced a very wide range of interesting variety of data to deal with. But rather than focus on the data for this talk, I want to discuss the tools that we used throughout our journey of working with this data so far. We'll have a look at the challenge that we faced of integrating and connecting these tools together to create a workflow, with the hope that this sparks some discussion about how widely software and tools are or can be reused for the management of marine data. And then we'll look at how we might be able to make small steps to overcome the challenge of integrating some of these tools. So firstly, I thought I'd start by taking you on a journey through the tools that we use and continue to use, and for what purpose. So after the initial expedition, when the data were returned to the institution, we used rclone, which is an open source command line tool for managing content on different platforms. And this was used to transfer the data to the university-run object storage and to back it up further from there to another object storage. And we do use a Python and Django application with a MariaDB database for managing some file metadata. But primarily this is used to store the data and sample collection metadata that came from the expedition itself, as well as some higher dataset level metadata that was recorded at the time as well. So here we come to the first open source tool that I wanted to focus on, which is Frictionless Data. And we use Frictionless Data to describe data files and their contents, as well as the group of data files that make up a dataset. And to do this, we use the schemas that are provided by Frictionless Data, which can describe tabular data files, such as a spreadsheet or a CSV file, and then the data sets themselves in a machine-readable way. For example, here we can see an excerpt from a data file description where a column name is specified, in this case longitude. And the data type itself is also specified as a number rather than, say, a string. Further information can be added to describe the field itself, and we could include bounding values as well, for example, and other parts of the schema that are included to describe the data files. Not only that, but Frictionless also provides some tools which can then be used to validate the data files and data sets against these descriptions that we've created. But this is where we come to one of our missing links in this tool integration. So we have our MariaDB database, which contains all of our metadata from the expedition, but currently we don't have a link to get that data into the Frictionless Data formats. So I've mentioned that Frictionless already provides some very useful tools to validate the data files and their descriptions, but they do also provide some which help to put together the metadata in a user-friendly way, or for somebody who doesn't want to sit and write, for example, a JSON file with the metadata. But we want to have a specific way of getting the data from this database into the Frictionless Data schema. So this would avoid us a lot of extra work and prevent some repetition of tasks, as well as ultimately allowing us to use all of the initial work that we did compiling the metadata in the first place. So a couple of ideas how we might go about this would be using maybe a Python script to extract the metadata from the database in combination with the Frictionless tools. But what may be more useful to the wider community, and perhaps more sustainable in the long run, is to contribute to the suite of Frictionless tools in this case. So after we've packaged the data with the frictionless data schema to make a fully described data set. We then have two different routes to publishing the data. Sometimes we import data into Renku, which is the next tool that I wanted to focus on. Renku is an open source collaborative working environment developed by the Swiss Data Science Centre, which allows full reproducibility of the workflow by capturing details of the data, code, and the environment that's used for any of this processing. Unfortunately, due to circumstances outside of our control, we didn't use Renku to its full potential in the majority of cases for this set of data, because we imported it into the program at quite a late stage and normally after any processing had been done. But in a perfect world, we would have imported the data straight after collection, and it would have been used within the system throughout the processing stages right through to publication in order to retain that fully reproducible workflow. So after the data had been incorporated into Renku, they were then published through Zenodo, which was a generic data repository, making them openly available and discoverable within several other data repositories as well, such as Mendeley Data, DataCite, and Google's Dataset Search. Now, Renku uses the Zenodo API to publish the data, so it's possible to publish datasets directly from Renku, and so this provides a nice opportunity to be able to automate the publication if we wanted to. But as I've already mentioned, we don't always incorporate data into Renku for a variety of reasons. So this is when we come to another one of our missing links in our workflow. Currently, if we want to publish any datasets directly through Zenodo, we need to do this manually as well. So this involves, again, repeating the entry of metadata into the Zenodo online form. But there is the Zenodo API, as I've already mentioned, so this would provide us with a really nice opportunity to make use of this. And as we already have the data stored in the frictionless data packages in a machine-readable way, this would be a good opportunity to try to integrate the tools better here. There has been some work to have a go at doing this within the frictionless data community, and we have been part of further discussions on this, but it's not in place as yet. So now we're reaching the final step in the process of our workflow so far, and this involves taking the frictionless data descriptions of our datasets and making sure that they're published on GitHub. From here, this allows EMODnet to have built some tools which take the data sets and incorporate them firstly into ERDAP and then into their data portal. EMODnet Physics provides a searchable map-based interface to marine datasets from different platforms and data providers, as we can see here on their map. And metadata from the frictionless data packages that we've seen are provided in the friction, then extracted and displayed here alongside each of the datasets within EMODnet. And we can see them alongside visualizations of certain parameters, which again are described properly within the frictionless data schemas. This also provides a link back to the original dataset using the DOI. So that brings us to the end of the tour of some of the tools that we use so far. And we've seen that there are certainly many available that we could use. Wherever possible, we've chosen to use community-led or open source tools which are freely available, which that allows us to modify the code or add features that we need. And of course, one of the huge advantages of using open source tools and having willing teams to work with on community-led tools is to be able to adapt them for your particular needs rather than having to custom build something particularly specific from scratch. Making improvements and adding features to these tools provides a base for others to work from as well, in turn feeding back features that may also be useful to us in the future. So the last part of the talk was I wanted to finish by talking a little bit about the challenge that we had of integrating some of these tools. And we've seen two particular points where we lack a connection between these tools that we do use. In many cases, we found that there's very little integration. There may be at least some similarities, perhaps in data formats or metadata schemas that are used, which would facilitate some kind of integration, but generally there's no specific way to do it. To bridge these gaps, we need knowledge of the tools and technologies that they are built with, and this is often required to be able to link them together. So it's somewhat assumed, really, that you need to be able to know a bit of everything, or at least be able to have a go at tackling the problem. Additionally, you might need further resources such as server infrastructure. So piecing together tools using scripts is a way to start, and we've done some of this as we've gone along. It's helped us in a few parts along the way. But as you saw, there's still a few crucial missing pieces. But I think what we can really say is what's helped us so much is collaboration with the communities that work on these different tools. So in particular, Renku, the Swiss Data Science Centre, EMODnet Physics, Frictionless Data Community, and rclone. And without the possibility of us being able to feed back to these communities, fixing bugs, suggesting and contributing to new features, as well as participating in the community efforts and events, we wouldn't have been able to bring together these tools together as we have done so far. And certainly using descriptions of data with Frictionless made our work with EMODnet Physics much more straightforward. So we still aren't at the stage where this is perfect, and there are many aspects that need work, but each small improvement brings us a step closer to a more robust workflow that hopefully would ultimately save time and prevent errors, improve the reliability of what we're doing, and scalability for future work. So to wrap up, we've seen that there are a number of tools available for anyone working with or managing data, and I'm sure there's many more that we'll discover during this conference as well. But it's important to recognise that time and some expertise, sometimes more and sometimes less, is needed to be able to connect these tools and use them to their full potential, rather than reinventing the wheel each time and creating something completely new. None of these tools would be as useful though without their communities and their knowledge, as well as good documentation. So being prepared to be part of the conversation about the tool and provide feedback is hugely important in some cases to be able to succeed in bringing them together. So we were lucky to be able to begin using Renku early on in its development as part of a project funded by the Swiss Polar Institute and the Swiss Data Science Centre. And as I've already mentioned, a huge thank you to all of our collaborators who work to provide the constant improvement to their tools and the valuable contributions of the communities as well that support the tools that we've mentioned today. So thank you very much for your time, and I'd be pleased to hear from you for more discussion around these topics.